Greeting everyone. This video is going to be talking about or introducing the aspects of the Coulomb's law.
Self, what is a charge? What is a charge? Let us look at the what we talked about in grade 9 atom. The atom. The atom of, let's say, for an example of helium. It has the helium is an element that is in that that is number 2 on the periodic table. So because it is in number 2 in the periodic table, so it has 2 protons inside the nucleus. So inside the nucleus there are also neutrons. Gonna represent them with the letter N. So it has the structure of a helium atom has 2 protons inside the nucleus. For it to be neutral, because now it is positively charged if it has 2 protons, for it to be neutral, it must also have 2 electrons on the shell, because we said the electrons are revolving outside the nucleus on the shells, on the orbit that we call them shells. So in mathematics, if you add 2x positive 2x plus minus 2x, what you will get is 0. So that is why we say the charge in this atom is 0. So if we are talking about an atom, let's say, okay, if we're talking about an atom, if for instance we remove one electron, if you remove one electron, you'll only be left with one electron in this case. So this atom is no longer neutral, but it is now positively charged because there are two protons and only one electron, which makes this atom positive. Although this would never happen to a helium atom because helium is a noble gas. Okay, so now helium is negatively charged. So if this atom of helium is now brought to another next to another atom that is negatively charged, there will be a force of attraction because helium is now not neutral. You will also like electron and become neutral. Let's say we talk about a ruler. A ruler, if it is neutral, it will have millions and millions and millions of electrons. But let's say for this drawing we only draw 1, 2, 3, 4, 5 electrons. If it has 4 electrons, therefore it will need 1, 2, 3, 4, 5 protons, so that it will be neutral. Okay, if this ruler if this ruler is rubbed is rubbed you rub this ruler using a cloth. This cloth is also neutral, so it has the equal number of the number of electrons is equal to the number of protons. 1, 2, 3, 4, 5 protons, 1, 2, 3, 4, 5 electrons. So this cloth is also neutral. So if this cloth is rubbed against this ruler, it will either transfer electrons from the electrons will be transferred from the cloth to the ruler. Electrons are not lost or gained. They are transferred from one object to another object. If this ruler now has one more electron than it has originally, this ruler, because it has more number of electrons than protons, it will have a negative charge. And this cloth, because it has more protons than electrons, it will be positively charged. Because if we take for an example, if a class is full of chaotic students, even though there are few students that are behaving in a class, because most of the students are chaotic, we will say the class is chaotic. So even in this case, because there are more electrons than there are protons, we say it is now negatively charged. And in this case, because there are more protons than electrons, we say this object is positively charged. Once these two objects are oppositely charged, each one of them will be attracted towards another. So this cloth will now be attracted towards the ruler, and the ruler will also be attracted towards the cloth, because they possess opposite charges. So we say like charges attract each other. So this force of attraction, the force of attraction between the two objects, will increase if more electrons are transferred from one object to another. So if 2 electrons or 2 million electrons instead of 1 million electrons were transferred from the cloth to the ruler, so the charge, which we give a symbol of Q, will increase. The negative charge in this ruler, in this case, will increase. And if more electrons are lost by the cloth, the positive charge of the cloth will also increase. So if the charge is increased for, on both objects, the force by which they attract each other will also increase. What else will also affect the force by which these two objects attract each other? It is the distance, the distance between these two objects. If we increase the distance, the force will decrease. But if we decrease or we bring them closer, the force of attraction will increase. So this brings us to what we call this brings us to what we call the Coulomb's law. So this is the Coulomb's law. It says that the magnitude of the static force if we represent this relationship using an equation, we say F is equals to K Q1 being the charge on the first object times Q2, which is the charge on the second object, divided by R squared, R being the distance between the two objects. And we say that K has a value of K has a value of 9.0 times 10 to the power 9 Newton meter squared per Coulomb squared in free space. So we can use this equation to solve any problem if we have to find the force of attraction or repulsion that exists between 2-point charges, if we are given the magnitude of the two charges and the distance between the two charges. And we can also get the distance between those two charges if we have the magnitude of the force and the charges between those two objects. So that is how we use the Coulomb law. In the next video we will look at solving some problems that involve the Coulomb's law. Thank you for listening to this video. Hope you enjoyed it. Bye bye.